Welcome everyone to my new video. Now I'm going to show you the AND gate, which is a fundamental gate, logic gate in digital electronics. So here now we have a symbol in digital electronics for AND gate. Here we have an output A and B, and here we have a truth table. So here is how it goes. If both inputs are 0, the output is going to be 0. If only one is 1 and the other is 0, also the output is 0. But if all the inputs or both inputs are on high level, then the output is going to be high. So in order to have 1 on the output, all logic inputs have to have a high level on the inputs. So here now I'm going to run the program. I'm going to show you how I'm going to simulate the program, and you will see now that just watch this particular part. So if both inputs are 0, also the output is going to be 0. If one is 1 and the other is 0, also the output is 0. So let me just simulate that. And as you see, if B is 1 and A is 0, the output is also 0. But if both inputs are on the high level, then the output is going to be on the high level. Okay, now I'm gonna show you the switch analogy, which is the most which is the oldest principle in digital electronics. The basics of electronics are switches and relays. So now I'm gonna show you if both the open switch here acts as 0. If if a switch is closed, then it acts as 1. So in order for this lamp to glow, the current must go from the plus to the minus sign. And if we have both or just one switch opened, there won't be any current through this circuit, so the lamp will not glow. So but if both A and B switches are closed, then the current will pass through the lamp and the lamp will glow. So now let me just set the animation option so you will see the flow of the current. Now when I run the program, just a second, then you will see that there is no current passing through this lamp. If I close only one switch, also there is no current because this switch is on. If I just close the B switch, also there is no current. But if I close the switch, then you will see that there is a closed circuit. In order for current to exist, it has to have its closed circuit. Now when I close this switch, which acts as 1, when I close the switch, it acts as 1, the lamp will glow. And here is a switch analogy for the AND gate. Now for the transistor logic, for the transistor analogy, if both inputs are on a high level, then the base will have an input current. So these these transistors are going to conduct. So there is going to be a voltage dropout that is slightly less than 5 volts on this resistor 10K. But if one is just on the low level, then it's gonna block the transistor and there is no current passing through the resistor here on 10K. So now here is that transistor analogy. Here we have always plus 5 volts. Here we have A input that is on 0 volts. Now we have B that is also on 0 volts, and here I put a voltmeter so we can measure the voltage on the resistor R3, which is also the output of this circuit. Now when I run the program, you will see that there is no voltage dropout on this resistor R3. But if I put 5 volts on both A and B, which acts as a high level, as a 1, and when I run the program, you will see that the current will pass through both transistors. It will pass through the R3 resistor, so there is a voltage dropout on this R3, and the voltage output here is 4.11 volts, which is slightly less than 5, but also in the range of a high level in digital electronics. And this is I just showed you the basic AND gate for 2 inputs. But also if you have more inputs, for example 3, 4, 5, 7 and 8, you can have multiple line inputs. You have multiple inputs also on AND gate. AND gate can have more inputs than just 2 inputs. So for example, it also goes on the same principle. The 0 is always on the output is always going to be 0. It's always going to be on a low level if all the inputs, if just one input is on 0, output is only going to be 1 when all the inputs are going to be 1. So when I run the program, as you can see, I have 2 levels, and any combination which there is only 1 0 here, it isn't going to change the state on the output. But if I bring all the ones, all the high level on the inputs of the AND gate, then the output is going to have a 1 on the output. Also the same here for 4 inputs, 5, you see nothing is changing until all the inputs are 1. And I just wanted to show you that you can have more inputs in an AND gate. So you can see, no matter, you can have 1,000 inputs, the output is always going to be 0 if just 1 or more inputs are 0. But the output is always going to have 1 if all the inputs of the AND gate is on a high state, or as we like to call it in digital electronics, their inputs are all 1. So I think I showed you everything for the AND gate, and thank you for watching, and see you in my next video. Goodbye everybody.